Okay, in this video I'm going to talk about what voltage is, or if we want to use the sort of old-fashioned but proper term, electric potential. So the short of that is that they used to call it electric potential, and they used to measure electric potential in volts, the unit, and then somehow at some point they started calling it voltage instead of electrical potential, and it caught on, and people don't really call it electrical potential anymore. The name is out now voltage. At any rate, the definition hasn't changed. It tells us how much energy will be released when 1 coulomb of charge moves around an electric circuit. So if we have a battery, that is, just draw like a little 9-volt battery, powering a light bulb, and we have electrons flowing through here, and we get 1 coulomb of charge. That's a whole bunch of electrons to flow through. If this is a 9-volt battery, that means that 9 joules of energy will be released when 1 coulomb flows around. So the formula here is that energy is equal to the voltage times the charge. So how much energy we get when we have 1 coulomb of charge. To understand this, what we want to think about is what is it that makes electrons want to flow around a circuit in the first place? Or how does a battery work? Essentially, batteries work by making regions with excess electrons and regions with deficits of electrons. So this object, for example, I've drawn 1, 2, 3 positives and 1, 2, 3, 4, 5, 6 negatives. So negative 6 plus 3. This region has a charge of -3. And alternatively, this region I've drawn 1, 2, 3, 4, 5 pluses and 1, 2 minuses. So this one has a charge of +3. So by creating these two regions, what happens is that electrons, we have to remember our basic law of electrostatics, like charges repel. And unlike charges, attract. So by creating these two regions where this one has a negative charge and this one has a positive charge, it means any one of these electrons, if there was a pathway between the two areas, would like to flow from this one, because this one's negative, so it repels, they're like, to this one, where it is attracted. It wants to flow, so if it wants to move from one area to another area, it can release energy as it moves from one to the other. When we figure, again, one more time, voltage is a measure of how much energy will be released when that charge is allowed to flow. How much energy? So that's what a battery does. It creates a negative region and a positive region, and then the negative electrons naturally want to be, when they're repelled from their own region and are attracted to the other region, they want to flow. So if we have something like a wire in a complete circuit, then they're allowed to flow. One more time, voltage is how much energy they release when they do flow. The analogy that some people would make here is that electrical potential is a little bit like the height of a hill. We can imagine if a ball was at the top of this hill and it went to fall down the hill, then as it moved down, it would release energy. How much energy it would release would depend on the height of the hill. So, in a sense, voltage is a little bit like height, as it is how much energy will be released when this electron is allowed to move from a position where it doesn't want to be, a negative spot, to a position where it does want to be, like a positive spot. So that's what voltage is. We're going to follow this up with videos on the other two ideas here, current and resistance. And then we'll talk about the basic components of electrical circuits and how all three of those things work to allow electricity flow around circuits and delivers energy to perform useful tasks.